I'm finally moving on to the fourth page of the test here. Test question 18, which is test hint 48. Describe the location of the electrons in the electron C model of metals. Please take a look at the animations that I have posted for you on Moodle regarding the electron C. The Brightstorm videos that we have for you, very good examples of what's going on with the electron C. In metallic bonding, we're looking at metallic crystals, really. And now, we're not just looking at those 1, 2, or 3 valence electrons in the s and p orbitals. Now the d electrons can come into play as well. And our whole transition metal block and our inner transition metal block, the d and f electrons, those actually break free. So here's our metal ions, and it's what we call a metallic crystal, so they're lined up in an orderly fashion, but their outer valence shell and the d block, if they have them, has broken free and formed all of these positive ions. These pictures always look like jingle bells to me, but I'm sure my artistic ability is not bringing that forth for you. Now, the valence electrons that used to be surrounding these atoms have kind of dispersed all the way throughout, and I hope my orange marker will show up a little bit for you. And these valence electrons are now sloshing in and about and around any given kernel. So the inner part of the atom, the nucleus, and the inner shell electrons are very archaically referred to as the kernel, K-E-R-N-E-L. Kernel, 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 kernel. Honors page question. So that's what that ion is. And then the valence electrons sloshing about, they're not attached to any one given ion. They could be around any one and all of them at the same time. So it's kind of mutual sharing. Now, what would happen, because I'm sure going to come up with properties in a test hint in a second, what would happen if I hit this with a hammer? Okay? If I hit this with a hammer and there's this buffer of all these additional valence electrons there, I can just get those to slide past each other very easily. We can bend metals into all sorts of different shapes with our various tools or with a hammer or sometimes even with our hands, because these valence electrons allow these ionic kernels to, the rest of the atom, to slide past each other very easily. The animations that I have posted for you on this are great because I can't animate this static drawing here and I'm just not that great of an artist. But we can also get these things to be drawn into a wire. We could scooch this down into, force this metal through a small opening, and we could get those ions to line up and form, be drawn out into a very thin wire. We'd still have the valence electrons in between there. And that happens because these electrons allow those atoms to slide by each other very easily. Okay, taking a look at test hint number 49, which is test question 19. Describe the interaction of light and the electron C in metals. Well, probably one of the most obvious characteristics of metals is that they're shiny. Our stainless steel, our gold, our platinum, our chromium, once they've been refined and purified, a lot of the other elements, metals as well, they're shiny and pretty. Why? Because light energy is coming in, electromagnetic radiation, and it's bouncing off of that. Okay? That electron C also allows the light energy to bounce off of the metal surface, and we see that as it's shining. Test question number 20, which is test hint number 50. Describe common properties of metals. 51 and question 21, the same thing. That's where those questions will be about shifting the layers of metallic atoms in a metallic crystal and what happens if you hammer it or draw it into a wire. So I've covered those already. And finally, test question number 22, test hint number 52. Compare the properties of metals and ionic crystals. Okay? And And I've alluded to this already, where I mentioned, well, what would happen if we hit these things with a hammer compared to what happens if we hit a metal with a hammer? And think about the oppositely charged ions in this crystal that would line up and where we'd have like charges near each other, and then they would repel and break apart. And we could easily envision dropping this crystal and breaking it into a million little pieces. But if we did that with a hunk of metal, all we're going to do is dent it or bend it or reshape it a little bit, because those electrons allow those atoms to stay stuck together as well. Okay, I think you're going to find this half of the chapter really pretty straightforward. There aren't many surprises there, and I did glance at the honors page before I set up the video camera tonight, and I have to say that there's probably on the honors page for this chapter, there's probably more questions related to ionic bonding and metallic than there are to covalent. And in fact, there's very little about metallic on the honors page. I know you guys get all worried about that, but it will be fairly straightforward as well. You will have to know a lot for this next honors page, because it will cover both parts of the chapter in one. Like we did with the last chapter, we're going to take the multiple choice test on each half and then put that all together into one honors page at the end. So, as always, happy studying. Please take a look at all the resources I have posted for you on Moodle. Get out ahead of the game and watch these test hints early now that you have them posted, and good luck on your test.
I know that love is just for people, but what about the microscopic world? Do atoms meet and fall in love, just like a boy and